Hello class, this is a video tutorial on annuities as a geometric progression, example 2. This video is going to be rather long, so I'm going to split it into two parts. Here we go. Aaron and Beth invest $10,000 on the 1st of July each year beginning in 2010, and the investment earns 8% per annum, compounding annually. How much will the investment be worth on the 30th of June 2030? Now it's important to note that 30th of June is one day before Aaron and Beth put another $10,000 in. Okay, so we will not be including the $10,000 on the very last investment. Now we should figure out how many years first between 2010 and 2030. Nice and simple. That's 20 years. So let's get straight to it. The first investment, actually you'll see I'll make this a lot easier for myself when I construct this. I'm going to let P be 10,000. Less writing for me later on. You'll see what I mean. So my first investment, the first installment is going to be that $10,000. This is compounding annually for, that's going to be for 20 years. The second installment is that $10,000 for 1.08, compounding for 19 years. This pattern can continue until the 19th installment. So the second from last installment is going to be the $10,000, 1.08. This will occur for 2 years. And the last one for the 20th installment is going to be 1.08 power of 1. For 1 year. We can take all of this and we'll find the total. The total of this, I'm going to start from the end until the beginning. So it's going to be P outside of 1.08 plus P outside of 1.08 squared plus P outside of 1.08 to the power of 19, P outside of 1.08 to the power of 20. Making my calculation slightly easier, I'm going to factor out P on the outside, leaving us with, I'm just going to copy this to make it a lot easier, everything here, but with P factored out. Now if you take a look, everything inside this square bracket is actually a geometric progression. So we can consider this as P times, do this in black, the sum of that progression there. And that progression, the first term, A, is 1.08. The common ratio is any term divided by the previous term. It's going to be 1.08. And the n, there are 20 terms in there, so that's 20. Now I hope you remember your sum of a geometric progression. It's going to be a outside of r to the power of n minus 1 all over r minus 1. Using these values here, 1.08, 8 to the power of 20 minus 1, all over 0.08. Substituting this back into here, or you can actually do that all in one go. I'm just showing you off to the side here. Putting all my values back in, P is 10,000. Outside of 1.08 Actually, makes it a lot easier for myself. I just copy it here. Just duplicate. Let's move it there. And inputting that into our calculator. Here we go. 10,000. Actually, I'll make it a little bit larger here. 10,000 outside of 1.08, outside of 1.08 to the power of 20 minus 1 all over 0.08. Oh, there's too many things there. 1 point. Oh, let me try again. 1.08 to the power of 20 minus 1. There we go. So this in total will give me $494,229. That's just to the nearest whole value. How much will the investment be worth at the end of the nth year? So in this case, we don't want just 20 years, we want any n value. So once again, I'm going to let P equal 10,000, it's just less writing for me. So the first investment is P times 1.08. But in this case, if it was 20 years, we put 20. For n years, we put n. For the second investment, it's P, 1.08. Well, it's going to be n minus 1. Because if it was 20, the next year is 1 less. So n minus 1. A, well, we're going to the 20th investment. So eventually we're going to have the nth investment. But the one just before that is n minus 1 investment. P outside of 1.08 to the power of, well, if you take a look, the second last investment was squared. So it's going to be squared as well. And the very last investment, well, that's just to the power of 1. Even if it was 20, it's the last investment will only occur for 1 year. Taking the exact same idea from here, the total, well, if you think about it, it's going to be the exact same. So I'm going to copy this total. Except, instead of 19, it'll be the second to last term. And instead of 20, it'll be the nth term. In the exact same manner, I'm going to factor out P outside of, well, I'm going to duplicate this. But because P has been factored, these expressions will no longer have P. And once again, P outside of the sum of this expression here. Highlighting all this in orange so you can see. In this case, A is equal to 1.08 again. My rate is 1.08, but this time N remains as N because we don't know what year it ends on. So substituting this into our formula, we get 1.08 outside of 1.08 to the power of n minus 1 all over 0.08. Substituting this into our expression here, or you could have just done it all in one go. Just showing you this off to the side so you can see. So it's going to be 10,000 outside of 1.08 1.08 to the power of n minus 1 all over 0.08. Evaluating all the terms here except for the n values, this will give us 10,000. Now I'm only evaluating these ones here in orange. So 10,000 times 1.08 over 0.08, leaving me with 135,000 outside of 1.08 to the power of n minus 1. So this expression here gives us the value of the annuities. Let's do this in green. This here answers our question of how much will the investment be worth at the end of the nth year. So I hope to see you in the next video when I answer these next two questions. See you then.